Good evening, students. So, in the previous class, we have seen up to the classification of organic compounds. Up to here, we have seen different classifications we have seen in the previous class. Today, we will see other topic like the first topic is functional group. What is functional group? This one. The functional group is an atom or a group of atoms. The functional group is atom or a group of atoms joined to the carbon chain, which is responsible for the characteristic chemical properties of the organic compounds. So that is functional group. That means what he is saying is in any organic compound different types of functional groups are available. Like here he has mentioned example of hydroxyl group or aldehyde group or carboxylic acid group. So these are the functional groups which are characteristic of the particular compound. This is aldehyde group and this is OH group and this is COOH group. COOH group. So this is aldehyde, this is OH, that means alcohol group, this is COOH group. So these are the functional groups which are the properties of the compound are depending upon. So for a given organic compound, its properties are depending upon these functional groups only. Alcohols have different properties, aldehydes are having different properties, acids are having different properties. So ketones, esters, amides, uh, all these are different functional groups. In detail, we will discuss that when we come to that particular topic. Like in IUPAC nomenclature, after two papers of this text, two papers of this textbook, so we will discuss IUPAC nomenclature. There, different functional groups we will see. There, we will discuss different functional groups actually. Okay, that is functional group. That means the properties of a compound depends on only the functional group of the compound. Those functional groups are around in organic chemistry. Nearly 15 to 16 functional groups are available. So those functional groups we will discuss in the next class. That means coming classes. Now the next one is homologous series. Okay, homologous series. What is this homologous series? Homologous series means suppose I have methane with me. What is the formula for methane? Here if we write methane formula here, this is H, this is H, this is H, and this is also H. So this is methane. Now in this methane, if I put in between these atoms carbon and hydrogen, if I put some CH2 group like this CH2 group, I incorporate in between this CH2 group, I incorporate in between carbon and hydrogen, then I will get what I will get here already CH3 and I am incorporating CH2 in between them, and again hydrogen I am keeping. Now this compound is new compound, ethane. So from methane, if I incorporate this CH2 group, it becomes ethane. In the same way, if I incorporate CH2 group in ethane, then it becomes propane. And in propane, if I incorporate CH2 group, then it becomes butane. That means just by incorporating CH2 group in the series, next higher member is obtained. Butane becomes pentane, pentane becomes hexane, hexane becomes heptane, like that. Another member will be appeared, another member will be delivered. That is called homologous series. It is series of compounds. Just by adding up CH2 to each of the lower member, we get the next member. That means methane became ethane, ethane became propane, propane became butane, just by adding CH2 group. So that is actually homologous series. So what he is saying, a group are a series of organic compounds, each containing characteristic functional group, forms a homologous series. That means that is happen. I just to give an example of alkanes. So in the alcohol also same. So for methanol, if we add CH2 group, it becomes ethanol. For ethanol, if we add CH2 group, then it becomes propanol. So next higher member will be formed. So in case of aldehydes, first aldehyde is formaldehyde. If we add formaldehyde CH2 to the formaldehyde, then it becomes suppose formaldehyde is HCHO. This is formaldehyde. And if we add in between these two, H and CHO, if I add CH2, then what it becomes? It becomes CH3 CHO, acetaldehyde. So formaldehyde become acetaldehyde. The same way acetaldehyde, if we add CH2 group, then acetaldehyde will be converted into propanaldehyde. Propanaldehyde, if we add CH2 group, it becomes butanaldehyde. So next higher member will be formed actually. So this is what member of the series are called homologous series. This type of just by adding CH2 and getting the next higher member is nothing but homologous series. Okay, the members of the homologous series can be represented by general molecular formula, and the successive members differ from each other in molecular formula by CH2 unit only. CH2 unit only. Why? Because we are adding only CH2 group. Okay, so there are number of homologous series of organic compounds, like alcohols are there, aldehydes are there, ketones are there. Just by adding up CH2 group to each of the compound, we get the next higher member. So some of these are alkanes. Here he has given the example: alkanes, alkenes, alkynes, haloalkanes. That means alkane containing halogen group. Haloalkanes means CH3, this CH3 Br. This CH3 Br is methyl bromide. So it is haloalkane. Haloalkane. It is haloalkane. The next member is, this is methyl bromide. Next member, if we add CH2, it becomes ethyl bromide. If we add CH2 to ethyl bromide, it becomes propyl bromide. So that's how the series grows. That is a homologous series. And alkanols also, alkanols also, that means aldehyde. Just now I gave formaldehyde, acetaldehyde, those examples. And alkanones, that means ketones. And alkanoic acids, that means carboxylic acid. And amines also. So for each of the functional group, whatever series you take, either alcohols, aldehydes, ketones, just by adding CH2 group, next member will be appeared. That is called homologous series. And it also possible that compound contains two or more identical or different functional groups. That means it also possible that a compound contains two or more identical or different functional groups. That means polyfunctional group. Is talking about polyfunctional group. Polyfunctional group means um, here I have this side aldehyde group and this side alcohol group. So it is nothing but 1, 2, 3, 3 hydroxy propanol, and this is called CH2, and this is also CH2. This the IUPAC name of this compound is 3-hydroxypropanol. So just by adding in between CH2 here in this bond, this carbon, just by adding here CH2, its next higher member will be appeared. So that's how we can prepare next homologous member actually. Okay, so that is the homologous series. And now after this we have uh, nomenclature of organic compounds. Nomenclature of organic compound, this one. That means the nomenclature of organic compounds means giving a systematic name to an organic compound. We have lakhs and crores of, that means millions and billions of organic compounds. Just by this homologous series, we can prepare, we can have in our means list lakhs, that means millions and billions of organic compounds. So for them, how to give the naming? Because so many organic compounds there. So IUPAC, that means International Union of Pure and Applied Chemistry, IUPAC, that gave some rules for giving names to the organic compounds. So what is that? Organic chemistry deals with millions of compounds, millions of compounds. Okay, so in order to clearly identify them, that means distinguish them, this is one compound methanol, this is ethanol, this is propanol, like that. For means distinguishing, in order to clearly identify them, systematic method of naming has been developed and is known as IUPAC, International Union of Pure and Applied Chemistry. Hmm? System of nomenclature. So here in this systematic nomenclature, the names are correlated with the structure such that the reader or listener can deduce the structure from the name. That means if we know the name, we can write the structure. If we know the structure, we can write the name. So like that, these rules are framed actually. IUPAC rules are framed. Okay. So before the IUPAC system of nomenclature here, however, organic compounds were assigned names based on their origin or certain properties. That means some compounds means little organic compounds are known. Those organic compounds are named from their origin, from where they are obtained. From that names were given. But as the molecules increase, compounds are increasing gradually with this homologous series. So that origin, giving the names by the origin is difficult. That's why a systematic naming is uh, developed actually. For instance, citric acid is named because it is citrus fruit here. So because it is found in the citrus fruits, citric acid. Another acid found in red ant is named formic acid, since the Latin word for ant is formica. So formic acid is obtained from, means actually ants, in ants biting and all. Why we get pain means ants contain formic acid. When that is injected in our body, we get pain actually. So that formic acid name is coming from ants actually. So in Latin, formica means ant. That is the origin for formic acid name. These names are traditional and are considered as trivial or common names, no, general names. Some common names are followed even today. Some common names today even we are calling chemicals. Chemicals are called by some common names actually. So, for example, hmm, you can say Buckminster fullerene is a common name given to the newly discovered C60 cluster. It is a fullerene. That means an means mm, it is a carbon compound actually. So a form of carbon, noting its structural similarity to the geodesic domes. popularized by the famous architect R. Buckminster Fuller. That means this Buckminster Fuller prepared a dome architect. He is an architect. He prepared a dome kind of building, actually architecture. So that architecture is similarly looking like a molecule, organic molecule. So that organic molecule is named after that structure by its constructor. That means architect, Buckminster Fuller. So that's why it is called Fullerian, Buckminster Fullerian. And common names are useful and in many cases indispensable, particularly when the alternate systematic names are lengthy and complicated. Just like acetone is there. Actually, acetone name is this is if we write the structure of acetone, this is acetone structure. Here methyl will be there. Here methyl will be there. So this is acetone. CH3 CO CH3. Common name is acetone. But IUPAC name is 2-propanone. Propanone actually. So second carbon keto group is there. So 3 carbons are the propanone. So IUPAC name is propanone and general name is acetone. So like that, some common names will be available. Some common names of organic compounds are given in this table actually. Trivial name, common names. Methane, common name and IUPAC name both are same. And this one is butane, N-butane, and this is isobutane. And this is neopentane. This is neopentane. This one, this one. This is neopentane. So like that, we can see some common names here: formaldehyde and acetone. This one is acetone, below one, and chloroform. Hmm. This is the below one is chloroform, and after that acetic acid. After that, this is benzene. After that, this is anisole. Like that, some common names are available here. Here you can see this is aniline, this is acetophenone, and this is ethyl methyl ether. Actually, this is ethyl methyl ether, but actually it is methoxyethane. IUPAC name is methoxyethane. Like that, common names are in use, and IUPAC name also we can write for them. So, how to write this IUPAC nomenclature and all, we will see in the next class. Thank you.